So this is peak index in a mountain array, Leetcode problem 852. So if you're given an array of integers, you are to return the index that is the peak number within that array of integers. So if you're given an array 0, 1, 0, you're going to return the index of 1 because the array is 0 based, so it's 0, 1, and 1 at the 1 index is the highest number when you ascend and then you descend. And in the second example, you're returning the index 1 because at index 1 is the number 2. So it goes from 0 up to 2. That's the peak. And then from there it descends to 1 and then 0. In example 3, you're returning index 1 also because it goes from 0 to 10. 10 is at index 1. And then once you hit the peak, you go down from there. Example 4, you're returning index 2 because it goes from 3 up to 4 up to 5. That's the peak. And then from 5, you go down to 1. And in our last example, you're returning index 2, which is 0, 1, 2, which is number 100, because you're going from 24 up to 69 up to 100. That's the peak. And then from there, you descend 99 all the way down to 19. Okay, so you can solve this in linear time, where you can just say, keep looking for numbers that are increasing, and then once it decreases, return that number. But the more efficient way to solve this is using a binary search. So whenever you're given an array that's in order, and this is somewhat in order, but you know the order is going to be going up and then down. So that's the given order. Binary search is the most efficient way to solve it. So when you have a binary search, you keep a left index and you keep a right index. Then you have a while loop and you say while the left index is less than the right index. When you're first into the while loop, you keep recalculating your mid. Then you're gonna check if that mid is the value you are looking for. If it is, you're going to return it. If not, if the value you are looking for is larger, you're going to set the mid to be the left side. So you're moving the window over so that the mid is now the left. Mid is now left, right stays, recalculate mid. If the value is less, mid is now right, right stays, recalculate mid. If we break the while loop and we don't find it, we're just going to return -1 because it just means there is no peak index that we can find, or something else is wrong with this input, whether there's 2 peaks, something like that. So hopefully we'll never get to -1, and -1, it means that there's no index that's going to be -1, so it just means it can't be found. All right, so let's make our left index. Left, and it's going to start at 0 because it's 0 based, and we'll make our right index, which is going to be the array length. And so we'll say while left is less than right. Let me make all of these in the right spot. Let's calculate our mid, which is going to be our left plus our right divided by 2. And I'm going to put a link in the description, but you have to do left plus right minus left to prevent an overflow whenever you're calculating your mid here in a binary search. So let's check if this mid is the one that we're looking for. So we'll say if in our array, if the mid index we're at +1 is less than, it means if it's descending after this one, and if it's ascending in the prior one, is less than. So that means if the value to the right is descending and the value to the left is ascending, it's the value to the left is bigger, and then if it's going up and then it's going down, then we found our mid, and we're just going to return that mid. So the mid is going to be the index. But if not, we're going to say if array of the value to the right of it is greater, that means if it's ascending, we have to move to the right. So the left side of where we're searching is going to be the mid +1. Else, we're going to just set our right is going to be our mid. And then we're going to recalculate mid, but we don't even really need to do that because our left and our right is going to be here in our while loop, so it'll automatically go back up to the top. And as this is reset, it's going to recalculate our mid. And if we get to the end of this while loop, we're just going to return our -1. Let's clean this up a little bit. Let's push this in a little so you see the logic. And this should be it. We can run this code. I was just using R and L when I should have been written out right and left. Okay, so that is accepted. Let's check this input. And we'll check our other ones and just make sure it's okay. So that should be it here. If you want, you can print out what your mid is during the time. And let's see here, for instance, we'll just say So when it's first run, the current mid is 0, 1, 2, 3, 4, 5. It's 78, and then the current mid is 0, 1, 2. We can do array mid. Let's see what that is. So yeah, first it says like it's 78. So is the value to the left, is it less? No, it's not. So it's going to go ahead and set it's going to keep the left value at 24, and then it's going to make the right value, it's not going to be 19, it's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be 78 there, and then it's going to find the mid value here, and then it's going to say that's the correct value, and then it's just going to return. Okay, so that's it. Let me just show you all of the code. And I'll just take this out too. It's kind of a mess. And that's a regular formula that you can apply for a binary search. It's just this if here is going to be the only logic that changes. Okay, thank you.